So the chapter 7 will deal with normal probability distribution. Remember, we looked in chapter 6 at discrete probability distribution, PD. Probability distribution or random variable. Probability distribution, PD, or random variable, discrete. And we looked at one in particular, binomial, with those 4 characteristics. Now in chapter 7, we're going to look at continuous random variables. Continuous random variables, and that is the normal probability distribution. And there is one other that we are going to look at, and it's called uniform. So uniform, we'll start with uniform, and then we'll look at normal. Uniform random variable or probability distribution, same thing, random variable, normal probability distribution, and random variable. Okay, so let's start and illustrate with about uniform first. So a uniform random variable, a probability distribution, same thing, very similar. Okay, uniform probability distribution has to have an area that is 1. And it has to have probabilities, as we know, between 0 and 1. And what is characteristic to uniform? Here's a graph of a uniform probability distribution. Something like, let's say we are expecting a package to arrive between 0 and 60 minutes. And this is the probability. This is the probability distribution. It has to have an area of 1. So it can represent, and we can discuss probabilities. If it has an area that is bigger than 1, we can discuss probabilities. Now, how do I determine this height? Well, as long as length times width is 1. So the area has to be 1, and this is length times width. I know the length is 60. What could the width be? Well, 1 has to equal 60 times what? So it must be 1 over 60. So this height is 1 over 60. Now, how do I determine probabilities for something like this? Let me move this because there are too many shadows here. Okay, so how do I determine, let's say, what is the probability that the package will arrive between 10 minutes and 30 minutes? All I have to do is determine this area. And that will give us this probability. So the area of this rectangle is base times height. So I continue here. What is the height? Well, it's 1 over 60. What is the base? Can anyone give us the base?
20.
Very good. That's it. So I will simplify. I have 2 over 6, which is 1 over 3. So this is the probability. Or if you want, 0.33333. Okay? That's the uniform. Now let's talk about, and we'll have examples in a minute. Let's talk about number 2, which is normal. Probability density. Probability distribution, same thing. Okay, so here is a picture of such a function that is normal. Here's the graph. This is normal. And it has many characteristics, of course. It's bell-shaped, symmetric. Symmetric. Right in the middle. It must have the mean the median, the mode, all of them are in the middle. The empirical rule applies here. The percentages, anyone remembers the percentages, the 3 percentages that we have in the empirical rule? First one.
67.
Very good. 68, yes.
95.
Yes. And 99.7. Awesome. Well done. Thank you so much. Okay. What is the area under the curve? Otherwise, it would not be a probability distribution function. What is the area?
1.
Yes, thank you. So the area equals 1. And the entire graph has to be above 0, right? Otherwise, the probability cannot be negative, right? The area must be 1. Now, something important about the curve, I do this with my calculus classes actually, it's something called inflection point, or in this case, points. Okay, so see the graph opens up. We say it holds water. And at some point, it turns and it doesn't hold water. And then at this point, symmetric, it turns again and it does hold water. Concave up, concave down, concave up. These are the so-called IPs, inflection point, inflection point. It turns out that they are exactly at mu minus sigma and mu plus sigma. In other words, this area is 68%. Okay? So in case we are asked, remember the inflection points are exactly 1 standard deviation away from the mean, left and right, on the curve. Okay. Any questions so far? Any questions?
No, thank you.
Okay. So I would like us to look at a particular example, and I have an example that I would like to talk about. Here it is. Interpreting the area under, I know you cannot see this, I'm going to copy it, but I just want to write it down together. The distance in feet a home run traveled in 2018 is approximately normally distributed with mean mu. So mu equals 400.3 feet, okay? And a standard deviation of sigma equals 25.6 feet. Draw a normal curve with the parameters labeled. That's our first question. Perfect. So here it is. So this is the normal curve. It's not perfect, of course. Oh, I forgot to mention that, of course, as x goes to negative infinity, these tails, we call them, will get closer and closer to 0. Not exactly, eventually maybe. Same thing on the other side. They will go closer and closer to 0. And this is called, you may have been taught this. This is a horizontal asymptote. Not super important. All I need you to remember is that these tails eventually will get closer and closer to 0. Okay? Okay. So this is the graph. It's not a perfect graph, as you see, but obviously this must be 400.3. This must be the inflection points, meaning this point is 400.3 minus 25.6, and this point here is 400.3 plus 25.6, and then plus 2, and then plus 3. Okay, so that's all I can present. Now, this is a random variable. It's continuous. We like to write this notation, so I would like you to get used to it. I'm going to write it again and again. So the random variable with this distribution is approximately normal or normal. And in parentheses, we wrote this before for z. We always write the mean first, 400.3, and the standard deviation, 25.6. I didn't have room to put it in. We know only one so far, that is normal. Can anyone remind us the mean and the standard deviation for the standard normal?
0 and 1.
Very good. 0 is the mean, 1 is the standard deviation. Awesome. Great job. Okay, so that was part A. Part B. Shade the area under the normal curve to the right of x equals 450 feet. Okay, so this is 400 plus 25. So roughly 450 may be here. 450. It says shade the area to the right of this. Okay, here it is. If I'm asked to find the probability that x is greater than or equal to will be no different. So greater than or equal to 450, I will say this is it. This is the probability, whatever that is, whatever this piece of the entire one area, this will be the probability that x is greater than or equal to 450. Let's see what they ask next. Part C, suppose that the area under the normal curve to the right of 450 is 0.026. Provide 2 interpretations of this result. Very good. So now they're telling us, and that's my page 3. They're saying, okay, this is part C. The probability for x greater than or equal to 450, because it's continuous, or greater than 450, they both mean the same thing, greater than or equal to, same thing, because it's continuous. They're giving us 0.026. Okay, so they're asking us to interpret this. So 2.6% is the chance of selecting x greater than 450 feet. Any questions so far?
No, for me,
Okay, so what else I can say about this? So the probability is this piece. What else can I say? Either the probability or the percentage. Same thing. So the percentage, that's one explanation. This is the second one. Because they are asking us to present 2. So that's what we're writing. So the percent of x values over 450 is 2.6. So the chance of selecting, this is probability, and this is percent. So two things come out of this area. Probability of selecting such and such, and percent from the distribution. So 2 interpretations. Okay, I think there was part D. Among all the home runs hit, what proportion exceeded 450? That's it. Percent or proportion, same thing. So these are the 2 interpretations of the area. Either I say if I in order to select something greater than a hit more than 450, that's the probability. What are the what is the percent or the proportion of all greater than 450 is this. Same thing. Good. I would like so far to stop for a moment and go to, I'm going to share my screen. And let's take a look at some, I have everything ready here for us to do some work. Okay. Okay, so here we have 20 questions. Let's see what we want to start with. And please, everyone get ready to answer.
Can we do question 9?
Let's start with number 9. Very good. Who would like to read it for us? I want everyone to participate, please.
I can.
Please, who is that?
Emma.
Emma, thank you so much.
Yeah, of course. It says draw a normal curve with a mean of 63 and a standard deviation of 12. Describe how you constructed the curve and discuss its features.
Excellent. So we have a mean of 63 and a standard deviation of 12. Remember how we write it. We should get used to this. So it says normal, mean, I think it was 63 and 12, right?
Yep.
Okay, good. So can anyone help next?
Do you want me to finish the question or
If you'd like to, it's up to you.
Okay, well, it's not C because C has 75 as the mean. So
Correct.
it's not that one.
Good. So we are disputing between these two. Yes.
Yeah. I believe that it's B because if you look at like the numbers, 63 minus 12 would be 51, and then 63 plus 12 would be 75. So
Right. We can always look and zoom in. So now let's see, where is the inflection point? Pretty much here, right?
Mhm.
So it opens up, it come about this point, it starts opening down, and about this point it starts opening up. Do not get tricked by what you see here. The graph does not touch the x-axis. Okay, continuous forever. So it appears that this looks great. Here, see, 63 plus 12 is not 77. So very good analysis. Awesome. This is it. Great job.
Thank you.
Thank you. Anyone else? Please choose.
There's a second part to that question.
Oh, of course. I always forget. Sorry. Describe how we constructed the curve. The normal distribution curve is centered at anyone else?
63.
Very good. Where is my keyboard? I still have a keyboard because I can't reach my computer is too far. Okay, and has 2 points of inflection.
51
Excellent.
and 75.
Since 75. So Madison and who was that? And Gavin?
Gavin, yeah.
Okay, and you said 75. Excellent. Wonderful. Very good. Okay, good. Let's move on. Anyone would like to choose the next?
Number 7, please.
Number 7, Preston. Good. Anyone would like to read it?
I will.
Perfect. Thank you.
The graph of a normal curve is given. Use the graph to identify the value of mu and sigma.
Excellent.
So I think the value.
I'm ready. You are probably muted or I cannot hear.
Professor, I'm not sure what happened, but I don't think we can hear you if you're talking.
Can you hear me now?
Yes.
Yes.
Okay, so I wasn't sure. I thought that somebody. Okay, can you hear me now, everyone?
Yes.
Yes.
Okay, I just didn't hear what you said.
I said 530.
Okay, and who is speaking because I can't see my computer so far?
Gabe.
Dave. Thank you. Excellent. Great job. And the value of sigma
2.
from 530 to 532. Awesome. Well done. Great. Well done. So the inflection points are here. Good. Okay, anyone else, please?
Can we do 11?
11, let's do 11.